Okay, so hold on, I am trying to trying to open several web pages just to show you. Just checking, can you hear me or not? So nobody can hear me.
Yes, doctor, we can.
So why nobody respond to my greeting? I said good evening, nobody respond. Okay, so it's good to know that you hear me. So first of all, so this session is conducted just because well, there are many questions. It seems that there are many questions being asked, and so that is why I conduct this session so that we can clear some things up, right, in terms of the mini project. Uh, okay, first of all, what maybe I can explain to you regarding the mini project. So first thing, the mini project is basically to provide you an exposure, to provide you an exposure on the real thing, more or less the real thing, because basically in your fourth year, in your final year, you will work on a plant design project, whereby you need to design chemical processes in order to produce certain chemical products. So basically, what that is what you will be doing at the end of your study, at the end your in your last semester lah. So basically, this is just this is just as an exposure, because if you refer to the mini project, so basically the process descriptions are already given to you, right? All the process description have been given to you. So basically what you need to do is just need to solve the unknowns, right, for the mass and energy balance problem lah. And of course it's not like your test, it's not like your final exam, for example, whereby all the informations are given for you, or maybe you have it in your book, whereby you can just refer to it and get the needed value, right? So this mini project is more or less like an open-ended type of problem, right? Whereby the information you need to find from whatever source that you can get. Okay, so that's the idea, right? So that's the main thing lah, to give you an exposure. Okay, and to provide you to make you realize that this is the reality, whenever you need to do perform mass energy balance, not all information that you need is available. That is reality. You cannot expect that all the needed data is available, right? Okay, so whatever it is, at the end of the day, what we want you to be able to do is that we want you to be able to solve all the needed, all the what you call the question. You need to be able to solve all the needed tasks lah, basically, in terms of calculating all the unknowns and calculating all the heat requirement and everything. So basically, all of those things you need to be able to do, which shouldn't be a problem because we are just doing theoretical calculations, not the actual one, right? Okay. So that is the first thing which I would like to enlighten lah, so that you are clear the reason why we are doing this mini project, not to torture you, but just to give you an idea of what is actually what's the actual situation lah, when you want to design chemical processes. It's not readily available, because in the normal case, in the actual case, if certain data is missing, then of course we will do what you are doing right now, right? We will look for the data from whatever database handbooks available out there, right? But the last resort would be conducting experiment, which you will not be doing lah, right? But in the real case, of course, they would opt for experiment lah, in order to get whatever information which is missing. Okay, so that is the first thing that I would like to enlighten lah. Okay, and next, I just would like to open for any question that you like to ask. I know there's a lot of question that you already asked, but I just want to hear it from you in this session. Okay, so any question from you? What problem do you have in trying to solve the mini project? Anybody?
Doctor,
Yes.
I'm Ayman from Team 11, Section 3, and I
Okay.
want to ask about reference state
All right.
for the
Reference
entire
state.
project.
Mm-mm.
Do we have to have one reference state for every stream?
Okay. Do you think what is your opinion on this, Ayman?
I think, Doctor, because we are asked to get the enthalpy for each stream, so we must have
Mm.
one reference state. Am I right?
So you think that there should be only one reference state?
Maybe, yeah.
Okay. Uh, well, to tell you the truth, it's actually up to you. But if you think logically, if you like, for example, I think maybe you can say, for example, if you refer to table B5, right? So table B5 is a steam table, right? Saturated steam table. Okay, for that particular table, how many reference state do you think that table have?
One.
One. Okay, what about table B8, containing all the gases? Are there many different reference states for that particular table?
I think same at the standard condition.
The same, right? So same goes for this. Okay, maybe I can show you. I'm sure you already have the copy of this mini project. I just want to show you this mini project. Wait a minute, I just want to show you. Okay, so this is your mini project description, right? So I'll just scroll down until the end. Okay, so this is table 1, right? So this is table 1, whereby in this table you would have all the information on the masses, and then you would have information on the fraction, small fraction, total enthalpies. So if you were to use many different reference state, then at the top you might need to write a lot of reference states lah. Stream 1 to 5, so this is the reference state. Stream 6 to 10, then this is the second reference state. The third reference state is for this stream. Then that wouldn't be convenient for me lah. So that is something that you need to think. Okay, so I'm not trying to because I don't want to answer directly whether you should only use one or many, but I'm just giving you a situation where I want you to think about it. Okay, so because here we have only one table here, so this one table would be for all for the process that we are designing here, or maybe you are given here lah. Okay, which is the production of 5,000 MTA of acetophenone from oxidation of ethyl benzene. And this is the table specific for this process. And at the bottom, you will find the entropy. So at the top, when you write the reference state, then should there only be one, or you need to write many for different streams? So that one, I leave it to you to think. Okay. All right. So do we have any other question?
Thank you, Doctor. May I ask another question?
Yeah,
Doctor,
sure, please.
can we use the heat formation for other processes that doesn't include reaction?
Can you repeat? Can you repeat, Ayman?
Can we use heat formation method for other process that doesn't include reaction, like condenser?
Okay. So the question asks you to use heat of formation, right, for the reactive processes. So which with respect to the reactors lah, right? So if the reactor is using the elements for the reference state, then what should be the reference state for the other streams? Because it will go back to the first question that you asked, Ayman, right?
Yes, Doctor. Thank you.
Okay, all right. Thank you, Ayman. Okay, next. Any other question?
Doctor, I have one question.
All right.
My name is Nazrul. I'm from section 4.
Okay, Nazrul.
Do we need to put down all the references for the value we obtain? Do we need to put like the link for
Of course. Yeah, yes, yeah. Please, maybe. Okay, so I would suggest for you to prepare a table, or normally what we call as a database. Prepare a database containing all the data that you get from whatever sources, and in that table, make sure that you have one column for reference. So in that column you write lah from Nice ke, from whatever lah, Paris ke. There must be reference so that when other people refer to your work, then they will know where you get the info lah.
Okay, Doctor. But Doctor, if we are doing the table, information table in both of our report and Excel, do we need to put the references in the Excel too, or just at the report only?
My suggestion, the table with the information should be in your Excel, because in your Word it's just step. First step what you do, next step what you do, and second and third.
Okay, so we need to put all the references in the Excel too, right?
Details in Excel.
Okay.
Word ni kita the word file is basically just for us to know the steps that you have taken in order to solve the problem from start
Okay,
until
thank you,
the end.
Doctor.
Right. Okay, next.
Doctor, is it the benzoic acid at the output stream of the condenser is in aqueous stage?
Sorry.
Is it the benzoic acid?
Benzoic acid.
Yeah. In the output stream of the condenser is in the aqueous state.
Which stream? I
Stream
don't memorize everything. You need to tell me.
stream
Stream 8.
yeah.
Stream 8.
Yeah.
Aqueous. Stream 8.
Yeah.
This is the component that you would have if you refer to this table.
Yeah.
When you see, because this is the okay, if you refer to table 8, okay, sorry, column 8. Sorry, stream 8, So this is the components that you have in stream 8. You have ethylbenzene, you have O2, N2, ACP, water, PMCBA, CO2, and NaOH. Sorry, and CO2 up until CO2 only.
Because I'm confused about the state of the benzoic acid, because in the stream of the condenser, which is the stream 7, it is in the vapor state. Then after the condenser, theoretically it will become the liquid state, but later we'll go to the neutralization. The benzoic acid suddenly become the aqueous state. So
Aqueous meaning benzoic acid with water.
So, in the inlet stream of the neutralization, the benzoic acid suddenly become the aqueous state.
No, you need to understand the neutralization reaction. You need to read the neutralization, because in that stream you have benzoic acid and water, and that solution will react with another solution, right, in order to produce the salt and the water.
Yeah, yeah.
Mm.
Oh, okay. Thank you, doctor.
The other question, for details you need to think on your own lah. In terms of calculation, you need to just okay. Before I forgot, okay, another thing that you need to do, that you need to include in your solution is that I'm sure, because from the question that you asked, I see that you have problem finding the information, right? Okay, so when you cannot find the exact information that you want, so you might want to use assumptions. So as engineers, we do a lot of assumption. Okay, so you also need to do you may need to use a lot of assumptions as well. And for each assumption that you make sure that you have justification for it lah. You need to justify, you need to assume. Okay, right. So that one you need to have in your report lah, in your solution lah. Okay, anything else?
Hello, doctor.
Yeah.
Can I know where can I find the CP value for sodium benzoate?
Where? Can you repeat?
About that. Can I know are there any references for CP value for SB? Because
SB, okay.
Uh-uh.
Tak jumpa. SB. So since you asked that, I want to share you something. Hold on. Can you see my Word file? Okay, so if you
Yes,
can see,
doctor.
if you can see this, so basically I have prepared this table containing all the substance or components in this project, and also with respect to the needed data lah, I presume. Okay, so the one that I tick is the data which I can find in the references lah, in the internet and everything. And the one that I dash, I assume that maybe it is not needed. And the one with this box are those information which I think is needed, but I also couldn't find the value lah. Okay, so if there are certain data that you still cannot find, then you should look further lah, and especially for those which I managed to find. So if regarding the question just now by, I think, Ryan, betul eh? So you asked me about the SB kan? So in terms of SB, so I can only find the value for the heat of formation solid and also the CP solid. Okay. So actually for SB, the melting point is 400 degrees Celsius, around that value. Okay, so actually when the neutralization process or reaction happen, the SB produced is more or less in terms of solid, dissolved in water lah. So you can assume it as solid, then you can use CP solid and HF solid. That's my suggestion. So we use assumption there.
Okay, thank you, doctor.
All right. Okay, regarding the sources of these data. Okay, one of course the main reference is your file the book. You have table B1, B2 until B11, right? So that's your main reference for the data. So another source of information for the data, maybe I can share with you. Okay, so the first source that you can refer to, which is quite reliable, is the NIST. I'm not sure whether you have. Let me, okay, this is NIST. Okay, you can go to this website, which I'm sure many of you have found this website when you try to search for the data. So this is one of the sources that you can go to in order to find the needed information, which is the NIST chemistry webbook. Okay, webbook.nist.gov. Okay, you can find all the needed information here. Okay, you can search by the name, by the formula, case number. Like for example, this one is benzene methanol alpha methyl. Okay, you can find the phase change data, for example, the delta H vaporization, and then phase change. Maybe I can write ethyl benzene. Okay, regarding the data, one of the difficulty with the data is that there might be many database out there, but some of it you need to pay, or maybe most of it. Most of the data that you can get, which are available out there, need to be paid, and you need to pay for it. Okay, only certain data are free. Okay, so that's also a challenge lah. So later on, when you work, maybe you need to design certain chemical process. Then if you need to have certain data, besides doing experiment, you also might need to pay for the database available out there. Okay, but of course, our limitation is only to find data which are free for you to get. Okay, and you can try looking the information here. So this is just an example for ethyl benzene. If you refer to this this part, the data available, you have gas phase, you have condensed phase. So gas phase is basically for gas phase. Condensed phase is for liquid phase. Phase change is involving well, if you have vaporization process, fusion process. So if you click gas phase, then you can find the here we can find the heat of formation in gas phase. You can also get the CP gas. Okay, and if you click the condensed phase, you can get the heat of formation liquid and the CP liquid. Okay, so this is one of the source that you can refer to. And another source which I found is this one, which is ethermo.us. Okay, but the information is quite limited. For example, here we can get the heat of formation here. And then there's another one which is cameo.com. Okay, you can write here the name of the chemical or maybe the class number, and here for this example component, you can see the values here, which are predicted values, and using these sources. So Jobac is an example of an equation written, and this is from NIST. You can get the HF gas, and you can get the CP gas, CP liquid. Okay, so from my search, I found out that these three sources you can get the most of the data. Most of the data you can get from these three sources. And another one you can also refer to Paris lah, Paris Chemical Engineer Handbook. And by looking at this data that I managed to find, I don't think that there would be a problem for you to solve the mini project. It's only that you need to find alternative and rather than the normal route. And for example, if let's say you want to go from Johor to Perlis, okay, maybe from Johor to Kelantan, maybe there's flood in Pahang, then you need to find other route. Okay, you need to find other route lah. You cannot go the normal route that you, for example, here PMC, right? So maybe many of you asked about PMC. So I also couldn't find, but if you can find it, then okay. I couldn't find the heat of formation liquid. If let's say, for example, PMC is in liquid phase, so maybe you can find other routes. You cannot go from elements to the PMC liquid, right? Through this route, so you find other routes, because you have delta HF gas, right? Okay, you can go from element to gas and then you condense it to liquid, right? You can do that, right? So that's another path that you can choose, because you learn about how to draw the hypothetical process path, right? So use that knowledge in order to go to create you can create your own path, from the reference state to whatever state that you want to go lah. But of course, provided that you have all the needed information lah. For example, here, so we have the HV for PMC, right? So you can use this path, from gas to liquid, for example. Okay, so you need to think about this. If you understand, then you should be able to do it. If you don't understand, you might have problem lah. Okay, so that is because we receive a lot of questions regarding PMC. And regarding the neutralization reaction, also there are some questions. If certain data is unavailable, you can do assumption. You can do assumption. You can use whatever assumption which is suitable. Okay, if let's say for example the heat of solution is missing or something, then you just make an assumption lah. Maybe the heat of mixing is neglected or something like that. Okay, but of course you need to try hard to find the information first. If you cannot find it, then you can use whatever assumptions lah. The thing is, if other team manage to find it, if I manage to find it, and you say you cannot find it, then that's the problem. Because there are 4 of you in one team, so I'm sure one of you would be able to find. You need to, yeah, it's not an easy task because you need to do a lot of searching and everything, but that depends on your skill lah, your search skill. All right, okay. So anything else that you want to ask? Because it's already 9:30. Okay, you don't worry about the answer. Don't worry about, okay, whether my answer is right or wrong. Because the thing is, like I said at the beginning, this is just to give you an exposure. Okay, so you just use whatever information that you manage to get, right? And then if you can't, if you don't manage to get everything, then you use some assumption lah, make some assumption, which are logic, right? And okay, so the thing is, because your mini project is 10 marks, right? So the answer is only 3 marks, but we are not looking at the right answer. We just want to see whether you get the answer or not. You calculate the answer or not. If you calculate the answer, then you should get the marks lah. Right?
Doctor,
Yeah.
I would like to ask the stream 17 and stream 23, the vapor fraction is 0 or 1?
Okay. We have an update on that. I will inform you later on that, because I haven't informed about that in our section. But I
Okay,
think other section have already informed on that.
okay, thank you, Doctor.
And regarding, because we also received one question on the sodium hydroxide, aqueous, right? So you said that the R value is 0 point something, right? 0.11, is it?
Yes.
Okay. Um, Actually, you can still use table B11. The thing is, you need to do extrapolation. You can do extrapolation. And because if you need to calculate something which is in the middle of info that you have, you are actually doing interpolation, right? Okay, if you need to get something which is at the end of your data, you can use extrapolation. It's only that in actual case, we don't. It is not advisable to do extrapolation. You can do interpolation, even though there will be some error, but it is not advisable to do extrapolation. But in this case, why not? You can do it. You can use you can do extrapolation in order to get the value at 0.11. Or if you decide to neglect the effect of water, then up to you. Justify it. Because in order to solve the problem, you need to be creative as well. It's not a direct solution, and you cannot memorize thing. You need to understand what you learn. You cannot memorize what you learn. If you understand everything, then you use your creativity, and you need to be able to solve it. You should be able to solve it. Okay. Okay. Anything else? Because this is the last day for you to ask question. Then the next 1 week we won't entertain any question. You will work on the project and submit.
Doctor, I have the question on the SB. I get the SB. I get the heat of formation of solid. Then just now doctor say the SB can assume as solid and it dissolves in the
Water.
water.
Mm-mm.
So can we use the heat of formation of solid for SB and
Yeah.
use the CP solution as water?
Yeah, up to you. You can use the assumption. You just justify. You write your assumption. You justify it. Why? You can do that. I have no problem.
Okay, thank you, doctor.
Yeah. Okay. Anything else? Okay. No question. All right. Okay. So thank you very much. So for your time, even though the info given is uh, quite late, because
Dr. Aziza, can I add some points? One
yeah,
point?
sure. Mm-mm.
Uh-uh. So, for the any assumption that you made, okay, I hope that you can justify the assumption in your report. I think it's better.
Yeah, of course. They need
Okay.
to justify because you cannot for example lah, if let's say you write okay your assumption pressure is neglected, that is not an assumption. There must be a justification on why you assume that the pressure is neglected. So every assumption must have justification. You cannot just write an assumption without any justification. Okay, thank you, Dr.
Okay.
Jamal. Because Dr. Jamal
Okay.
will be marking all your project, all submission from all section. Dr. Jamal will be marking. Right. Okay,
Dr.
so
Jama,
that's all. Huh? Okay.
one last question for Dr. Jama, please.
All right, sure.
Dr. Jama, can I ask how will this project be marked? Like, what is the marking scheme for this?
Actually,
How will we know?
in the mini
Yeah,
project, it's already mentioned
it's
at
already
the
mentioned.
yes, it's already mentioned. Look at
Yeah.
your project
15.
descriptions. Yes.
3 marks for process flow diagram, 2 marks for data interconnection, 2% report. I already mentioned about this during the briefing. I'm not sure whether you were in the representative or your friend did not tell you everything during the.
Okay, sorry and thank you.
Okay.
Doctor, just now doctor say we need to put the reference in the table. So we
Yeah.
need to we can just put the website name or we need to put the link.
Both. The name and the link.
Oh, okay, thank you.
You can just write, for example, NIS. What was it? For example, if your reference is from NIS, you can write NIS chemistry webbook, and then you provide the link.
Okay,
Right.
thank you.
Okay. Thank you very much. Have a nice day. Just to nothing, nothing more. Thank you. Thank you. Okay. Bye.
Much.